I'm Kosuke Nakano from SISSA, Italy, and from JICE, Japan. I'm in TREX project. I'm contributing to work package 2, TREX.io, and work package 5, the application, and also I'm contributing to summer schools. And I am one of the main developers of TurboRVB, and recently I launched a Python wrapper of TurboRVB, which is called TurboGenius. TurboRVB implements beyond selector determinant attacks such as Geminal and also Pathian. This is very important for studying especially strongly correlated materials, also materials at high pressure, because in these conditions the density functional theory sometimes fails to predict the properties of the materials. We can compute forces, atomic forces, using quantum Monte Carlo, because this is very important, because in quantum Monte Carlo computing forces is not trivial compared with DFT. In DFT almost all codes implement force calculations, but in quantum Monte Carlo this is not. I recently launched TurboGenius, which is a Python wrapper, which is the user-friendly code, is very beneficial, right, for users. So I decided to launch this Python wrapper to make the TurboRVB more user-friendly. Thanks to TurboGenius, in my opinion, I believe TurboRVB is now becoming more user-friendly and more and more user-friendly. And then also, thanks to TurboGenius, we can also perform a kind of high throughput calculation at the quantum Monte Carlo level, which is also very useful for future material science research. DFT sometimes fails for, let's say, very peculiar materials. In such cases, we can the quantum espresso plays a very important role to study physical property of these materials. For TurboRVB implements, as I mentioned, implement force calculations, which is very important in material science community, because, for example, structure optimizations or phonon calculations are doable using TurboRVB, as recently we published in some journals. TurboRVB can compute forces, so using these forces we can construct a machine learning potential, which is very successful so far, as recently submitted to arXiv. TREX project, we are also working on very high throughput calculation combined with AIDA. So in the near future, as done in the DFT community, we can also perform high throughput calculation at the QMC level. So this is very nice, because to design materials at high accuracy, we can. So in my opinion, yes, it's very important for material science research, especially to design new material in the future.